Hi, hello, year 10 students. Okay, so we are going to have our third lesson in the first week, right? So before we start our lesson, please remember to get your pens and notebook ready for the lesson, right? Okay, so this lesson is our last part of our expansion of binomials. Okay, so we are going to do difference between two squares. What's the difference between two squares? Okay, so let's see if I have two binomials with a plus b and another one's a minus b. Alright, so what are we going to have as our expansion? Okay, so let's see if we use FOIL. Still remember the FOIL? Okay, F for first, right? Okay, so that means we have a square. Okay, right? Okay, possibly should write a times a as our first term, and FOIL means the second one is O. O means outer. Outer means we use the first term of the first bracket times the second term, the second bracket. Okay, that's a times minus b. Okay, so a is positive, b is negative, so positive times negative becomes negative, isn't it? Okay, so it's minus a times b. So that's our second term. Okay, and our third term should be I. I means inner. Inner means the second term of the first bracket times the first term of the second bracket. Okay, that's positive b times a, and also a is positive, so two positive times together, you got positive b times a, right? And the last one would be L. L means last. Alright, so it should be the last term of the first bracket times the last term of the second bracket. So that's b times minus b. Okay, so what do we have? B times minus b. B is positive, minus b is negative. So positive times negative gives you negative minus b times b. Okay, right, so let's write the answer. Okay, so the answer would be a squared minus ab plus, okay, b times a actually means a times b, right? Minus b squared. Okay, so our final answer would be a squared minus b squared, because minus ab and plus ab, these two terms are like terms, but one is negative one, the other is positive one, so they cancel out each other. So the final answer is a squared minus b squared. Okay, make sure you understand this, why the answer is a squared minus b squared. Alright, okay, so that gives us our answer. Okay, so remember, when you have a plus b, that's the sum of two terms times the difference of two terms, and the answer is the square of the first term take away the square of the second term. That's why we call it difference between two squares. Okay, that's for the answer. So the answer is difference between two squares. All right, okay, let me create a bit of space so I could write our answer here. Okay, so basically that means, okay, if I have difference between two terms times the sum of two terms, then what are we going to have is the difference between the first term, the square of the first term and the square of the second term. Okay, so that would be our blueprint, our template for all the question like this. Alright, if you see the product between the difference between two terms and the sum between two terms, okay, if you multiply them together, then you will have the difference between the square of two terms. Alright, okay, so let's see if we have the understanding for what we have learned. Okay, so for a minus 2 times a plus 2, do we see the product between the difference of two terms and the sum of two terms? Yes, because that's what we call the difference. The difference between a and 2, and this one is what we call the sum between a and 2. Okay, so we got the difference multiplied by the sum. Then we could use the above result, right? So you just write a minus 2 a times a plus 2 equals, okay, the difference between the squares of the two terms. Okay, so that means the square of the first term, which is a, take away the square of the second term. Alright, so you need to simplify that a little bit. So that will give you the answer, right? Okay, let's see part B. Alright, so do we see a difference between two terms and the sum of between two terms? Yes, this time the first binomial is the sum between two terms, and the second binomial is the difference between the two terms. But essentially they're the same. Alright, you might put the difference in front of the sum, or the other way around. You will always have the same answer, because we know that's the multiplication. You can change the order between two terms, right? Okay, in this case, we are going to apply the same skill. Alright, so I'll give you a few seconds to think about your answers. Alright. Okay, are you ready? Okay, so the answer will be the square of the first term, then take away the square of the second term. Okay, okay, so that will give you the answer, right? Okay, so you see, when we know the result of this special combination of binomials, we're not going to use FOIL method, although FOIL method could give you the same answer. But using FOIL method, that means not more steps. Okay, a lot more steps. Okay, you need to expand all the things. You need to simplify, collecting like terms. Okay, and you got the final answer. Right? That's what we are gonna do. Yeah, what we are going to do is to use that result directly. If you see that's the difference times the sum, then the answer just be the square of the first term, take away the square of the second term. You are not going to use FOIL anymore if you see the pattern of the given binomials, right? Okay, let's do more. Okay, so this time I give you 2p instead of just one single polynomial. You got the you got a number times a polynomial in the two brackets. All right. Okay, so you got 2p plus 1, 2p minus 1. So this time, again, you see, okay, that's the sum. Multiply by what? Multiply by the difference. Okay? So when the sum of two terms multiply the difference of that two terms, then we can apply our rule again. Okay, you don't use FOIL again, alright? 2p plus 1, 2p minus 1, okay, equals 2p squared, the square of the first term. But wait a minute, if you just write 2p squared, anything wrong? Of course, if you just write 2p squared, that square has nothing to do with that 2. But we know that 2p is a single term. So in this case, like many cases we have done before, you need to add a pair of brackets here, right? And so the first term is 2p, the whole 2p squared, that means bracket 2p squared, take away the square of the second term. Okay, that's 1. Okay, how about 2p squared? It's not just 2p times, it's not just 2p squared, right? It's 2p times 2p minus 1. And 2p times 2p, you can always shift that 2 in front, so that 2 2's times together, and also that 2 p's times together, right? So you got 2 times 2 times p times p. Remember this? So you got 4p squared minus 1. It's not 4p, but 4p squared, right? Okay, so that's the first pair. Can we do a second one? Okay, so again, this time you got the difference in front of the sum, but we know that makes no difference for your for the method we are going to use. You are going to still use the same method as the difference or between two squares, right? Okay. Okay, let me give you a few seconds to think about our first step. What are you going to write? Your first step. Okay? About 10 seconds to make up your mind. Okay, let's see. So my answer would be the square of the first term and the square of the second term. But of course, the second term is not just s, it's 5s, so you need to have a bracket. Alright, and you got 9 minus 5s times 5s. Okay, we all understand that. That's 5 times 5, 25. And don't forget times s by itself. S times s, s squared. So that will be the answer. Okay? So that's our second example. Make sure you understand this. Alright? Okay. So let's see our last type of example. This time you see there's a number outside. Alright? Okay. So I'm going to give you some time to try to figure out how to do things when you got a number outside and some brackets after that. Okay, you might refer to our previous example. Right? Okay. Let's pause the video a little bit for a while to let you think. Okay, any idea? Alright, so remember that if you have a number in front, you need to deal with the brackets after that number first, and you then multiply that number into the bracket by using distributive law. That's the way we deal with our previous examples with other types of binomial expansion. Okay, let's see what happens for this one. Okay, first of all, I'm going to leave that 2 alone. I'm not going to touch it. Okay, so I just think about the brackets after that, there are two binomials, x plus 1, that's the sum, and x minus 1, that's the difference. So that's the product between a sum and the corresponding difference. So that's what we're going to have is x squared, the square of the first term, take away the square of the second term. Okay? But if you leave your answer like this, it's wrong, because you need to understand that 2 is left behind, left alone. But the thing you've done is belongs to the bracket. Belongs to the two brackets after 2. So that means the things here should be all multiplied by that 2. That's why you need to add a pair of brackets to keep that 2 away. Alright? And what happens here? X squared minus 1. Then of course, you got 2 outside. We are going to expand. So that means you have to multiply that 2 into the brackets. So that's what we call distributive law. Okay, so 2x squared, of course, minus 2 times 1 is 2. Okay, so how about a second question? Okay, possibly for you, if you want to try by yourself, you can pause the video now and try to do it by yourself, and then you check against my answer, right? If you really want to do so. Okay, so first of all, that's minus 3. I'm going to leave it alone at the moment, and then we are going to do the product between difference and its corresponding sum. Okay, so that's what we have. We got 2 squared minus what? Y squared. Okay, remember the bracket. Okay, minus 3, 4 minus y squared. So minus 3 need to multiply into the bracket. Okay, be a bit careful here. When you multiply that's minus 3 to 4, it becomes minus, because that's negative times positive. But if you multiply that's negative 3 to that's negative y squared, is negative times negative becomes positive, right? So it becomes positive 3 times y squared. Okay, so minus 12 plus 3y squared. Okay. So that all the questions are for this type. Okay. So in the handout I gave to you, there are extra examples. You might have a look. All right, and you can do the exercise here. Exercise 7.2. That's question 10. Okay. So let's give you a bit of exercise to familiarize yourself with this type of questions. Alright, okay, so try to do some questions in practice 1. Alright, okay, before you move on. Remember to check the answers as well. Okay. Okay, year 10 maths. Okay, if you have tried practice 1 and if you done, you get most of them correct, you know how to do them, then it's time for us to do a bit of revision of all the expansions we have learned. Okay, so that's what we call a comparison between different types of expansions we have done. Okay, so basically to do expansions, there are 4 ways to do it, 4 skills. One is what we call distributive law. That's for our you have learned that since year 7, right? Since year 8, right? So that distributive law. What kinds of question are we going to use distributive law? Think about that. All right. And of course, FOIL. FOIL means first, okay, outer, inner, and then last. Square of binomials, of course, is about square, difference of squares. Okay, so that's what we have just learned today. Okay, so let's see the first one. the first one. A plus b squared. So you see a square there. So it must be the square of binomials, right? Okay, so let's link this one to here. Okay, how about the second one? So that's a minus 2b times a plus 2b. So what type of question it is? Is it for you? Because of course all the questions here except one you can use for you, but normally if we have a ready-made result, we're going to use that shortcut, right? So for this one, is what we call difference of square, because you got sum multiplied by a difference, all right? So and this one, a minus 2b squared. So you see a square of a binomial. So again, it belongs to here. How about this one, minus 6 outside, a plus 2b. That's that single term multiply a bracket of two terms. Okay, so that's what we are going to use. We are going to use distributive law. Okay, and the last one is 2a minus b, a plus 2b. Okay, so you see it's like a difference multiplied by sum, but you see that 2a, but here's a. So yes, it is a difference multiplied by sum, but it's the difference and the sum, they are not corresponding. Unlike this one, they are really corresponding. A minus 2b, a plus 2b. So you need to have the same terms, but you have minus and plus in different brackets. But here, the terms are not similar, right? 2a and a, they are different. So this one, we're not going to categorize this as difference of squares. What you are going to do, you are going to use for you. So if you can't use any shortcut, use for you. Okay? So basically, we could understand this. Okay, so when we are going to use distributive law, you got single term outside, right? Okay, when we are going to use square of binomials, you might have things like this. All right, you got two things or minus. It could be plus or minus. There are two types of square binomials. When you are going to use difference of squares, you are going to see a sum multiplied by its corresponding difference. Okay, you see it must be circle plus square times circle minus square, or the other way around. Okay, and for you means you don't have any pattern of two binomials, but you want to expand them. So that's the time you use for you. It could be circle plus square, but then you might have something else. For example, you might have a triangle, and you might have another triangle, but inverted. So you got different. You see, you got different terms. So in that case, you have to use for you. Okay. So it's very important for you to understand what we have learned, and what time you are going to use what skills. Okay, so for different type of binomial expansions, you are going to use different skills. Okay, try to make sense of it. Try to get these pictures into your mind. So when you see the questions, different type of questions, they are going to be mixed up in the examinations. You know what kinds of skill you are going to use. Okay. Right, next, can I give you some examples? All right. So, for example, if we mix things up, what are we going to do? For example, when you are going to expand and simplify, so in the same question, you will see the square of a binomial with plus, and the square of another binomial with minus. But anyway, we are going to face a situation with square minus square, right? Okay, so what we're going to do, Okay, so for the first part, what we're going to do, okay, for the first part, we are going to expand it using what? We are going to expand it using the rule for the square of binomials. So still remember that you got the square of the first term, and you multiply the first term with the second term, and you double them, and then you plus the square of the second term. Okay, so that's for our first part. Okay, so that's what you are going to have. Okay, so what's this? X minus 1 square. You have, okay, so minus sign here. You have the square of the first term, and then you minus the product between the first term and the second term, and you double them. Oh, be careful here, it's minus, right? Because the sign here is minus. Plus what? Plus that 1 square. Okay, and you have x squared minus 2x plus 1. Okay, and then you are going to solve this question. Okay, so the question is like this. Alright, so what I'm going to do is to copy the answer I've got. Okay, then be a bit careful here because that's minus sign. So if you just write the answer like this, it's wrong because first you need to expand the second term and then you do that takeaway. But for that square of the second term, you got x squared minus 2x plus 1, right? But that's for the second term. It's nothing to do with the minus sign in front of it. Okay, so you need to add a bracket for it for the protection. If you are not quite sure, you just add the bracket. There's nothing wrong with adding the bracket. Even for the first term, for the first square, if you want to add a bracket, it's still okay. Although it's not necessary, because adding a bracket for something you have expanded is always okay. But whether it's necessary is another question. Okay, so the first bracket here is unnecessary, but the second bracket is necessary. But even you add brackets for both expansion, that will be okay. There's nothing wrong with this. Okay. Okay, the function of the bracket here, and to show you away from the minus sign, because after you remove the bracket, you need to take into account that's the effect of that minus sign. So that minus sign will change the sign for each term in the bracket. So for example, the first term is plus, so it becomes minus. Second term is minus, becomes plus. The last term is plus, becomes minus. Alright, then you need to collect the like terms. Of course, x squared with x squared plus x with x, and the numbers p and constant with constant. So x squared minus x squared, 0x squared, so there's nothing left. 4x plus 2x, 6x. 16 minus 1 is 15. Okay, so that will be the answer for our first question. Alright. And then have a look for this one. For the first part, you see there's x plus 3, x minus 2. What skill are you going to use? Okay, so we see, is this a square of binomial? No, there's no square. Okay, is this a sum times a difference? Partially yes, but the sum is not corresponding to the difference because the terms are not entirely the same. Because you see that's 3 and the other is minus 2. So that means you can't use the difference of two squares. What you can use though is FOIL. Okay, so if there's nothing for the shortcut, then use FOIL. Okay, remember the FOIL? Okay, that's first x times x. And then you move to the next term. That's outer, right? X times minus 2. Okay, that's positive and negative, so it becomes negative. Alright, and the third term. 3 times x, right? Because both are positive. And the last one, 3 times minus 2, right? Okay, so that's minus 3 times 2. Okay, so now your answer is x squared minus 2x plus 3x minus 6. Okay, don't stop here. You still got something to do. Minus 2x plus 3x minus 2 plus 3 plus 1, right? But we don't need to write that one. You just write x minus 6. Alright? Alright, all good. And you need to deal with the second part of the question. So how about this one? So you see that's the difference and the corresponding sum. You just need to compare. So you see 3x, you see 1, minus 1, and plus 1. And one's negative, the other's positive. So that means we're going to use the latest skill we have just learned. That's the square of the first term, with brackets of course. Take away the square of the second term. So that's 3x squared. Remember, that's 3x times 3x minus 1. So then 9x squared minus 1. Okay. Okay, so then we need to combine the two things together. Okay, we'll have this one. So let me write the answer for the first part. That's the answer, right? For the second part, this is the answer, right? And we have to use the first part to take away the second part. Okay, because that's a takeaway in the bracket here. Okay, so and then see what happens here now. Change the sign, because that's minus sign in front of bracket. Change the signs in the bracket for everyone. Okay, collect the like terms. So that's only 1x, alright. X squared minus 9x minus 8x squared minus 5. So that would be the answer, right? Okay, alright. Okay, make sure you've got all the answers, copy and try by yourself. Okay, in the notes, let's see. Okay, so that's practice 1 for the last skill we have learned. Alright, so there are more questions. Question 1 to 3, okay, you don't need to do question 3. Okay, sorry, question 3 is not necessary. I'm going to cancel it anyway in my final version of the notes. Okay, and question 4 is another multiple choice questions. Okay, so possibly you need to spend some time on question 9 and question 10 because they are mixed questions here, right? Okay, so remember to do the homework. So the homework is practice 1 and also the mixed practice. Just do as many as you can, right? Okay, see you next time.